19 appearing?
Yes, sir.
Yes, sir.
Alright. So this is the history of the quinine, that how it was discovered. Basically, this was discovered long time ago. More than 200 years ago. So it was known that it is a good remedy, but people were using, local people in South America were using quinine as a remedy already. So, but when this reached to the Europe, so European people start invading South America and bringing this bark from there. And later on, they cultivated this to a large extent, and these plants were used as a remedy to fight against plasmodium in malaria. So later on, the scientists, when the chemistry advanced, different chemists start working on this, and they work on the structure of this molecule. So this has been observed that when the different analyses were done, for example, when bromine, it was reacted with bromine, so the color of the bromine discharge, and this was observed that one equivalent of bromine color discharged. What this indicate? There is a olefinic carbon-carbon double bond present in the molecule. So if there is present, so this was indication that this functional group basically undergo bromine, it decolorizes bromine, bromine adds to this one. So this was the information coming by the addition of bromine, right? So this is present. Similarly, hydrogenation was also done. So when the hydrogenation was done, so it doesn't give much information about that. One information that was done is that when this was reacted with uh, iodomethane, when it was reacted with iodomethane, so it forms a precipitates. Precipitates are definitely ammonium salt, and it is observed one equivalent of that being used. Either this nitrogen, you can see this is sterically crowded, so definitely it doesn't undergo. If this nitrogen undergo, this is not sterically crowded, this has been protonated. This nitrogen is also tertiary. This nitrogen is also tertiary. You can see this nitrogen, either this methylate or this methylate, we shall get a positive charge on the nitrogen. If we are getting a positive charge on the nitrogen, so what we shall get is, we can see that one of the nitrogen in this molecule is tertiary amine. One equivalent of iodomethane is being used. Similarly, when in this molecule, if this R is hydrogen, this is called synconine. This is a structure that if this R is hydrogen, this is called synconine, because this is derived from cinchona. The cinchona plant and the quina. This word quinine is derived from quina, Quina. Quina, again quina. Quina is the name of the plant from which quinine was first discovered. And then cinchona, this is another plant, not quinine, but from cinchona, if you have a hydrogen here, it is in cinchona. In quinine, we have a methoxy group present here. This is a structural change. Otherwise, this all nucleus is same. This all nucleus is same. So it is having a pyridine type 6-membered ring fused with a benzene ring. So this is our quinoline alkaloid. But look at here, it also contains another nitrogen, which is also cyclic. It is making a 6-membered ring, a board conformation here. 6-membered ring it is making in this form. So this is a pyridinium type as well, which is this one, just like this. So this is a called quinoline alkaloid on the basis of this nucleus. We are calling this quinoline alkaloid. Otherwise, you can call this pyridine alkaloid, right? But this is the basic precursor. So this is the difference in structure of quinine and cinchona. So cinchonin and quinine are both anti-malarial agent, but cinchonin is more active than quinine, right? So similarly, some information was done when these were reacted with, in fact, chromic acid in sulfuric acid. So chromium oxide CrO3 when reacts with sulfuric acid form chromic acid. So when it reacts, so interestingly, two compounds were obtained. One was at that time called quininic acid, other was called meroquinone. Why this was called quininic acid? Because in quinine we are having a methoxy group present here, which is this one, and this bond basically breaks from here. What happens is that this bond breaks from here. It undergo oxidation into ketone and ketone, then carboxylic, and it converts into carboxylic acid group as well. So chromic acid breaks this carbon-carbon bond and cleaves this into oxidizes to carboxylic acid, and this carbon also carboxylic acid, and this bond of nitrogen with this breaks as well. So we get a nitrogen with hydrogen and six-membered ring, which is this one, NH, CH2, which is this one, and this group is above the plane, which is above the plane. This group is hydrogen is behind this group CH2, and this carbon converts into carboxylic, which is this one. And this carbon undergo carboxylic acid. This is called quininic acid. This is called quininic acid, and this is called meroquinone. Later on, interestingly, this quininic acid has been isolated from some other plants. So when the data of this quininic acid obtained from this was compared with already natural product existing, so it shows same chemical reactions. So this confirms that this quininic acid part, this part it means this carbon and this part. This is been reported that this nucleus is present within the molecule. Similarly, meroquinine structure was further confirmed. It has a acidic range, but it exists in Schweitzer form because it produces H positive ion. It is been protonated. It is just like an amino acid. So this produces H positive ion, same molecule, nitrogen gains it. So it forms the Schweitzer just like uh, amino acids. So this structure was separately confirmed. So when these were joined, so it means they are present in this form. Similarly, when these molecules are reacted with acetic anhydride, so what happened? One equivalent of that is used. So this is reacting with alcohol. So it means it forms the acetate moiety here. It means we have a OH group present here. Tertiary amine group has been confirmed by reacting with idomethane, and one carbon-carbon double bond was confirmed. And similarly, quick reaction with chromic acid results in the formation of these two fragments. The structure of these two are further confirmed so that we can conclude this structure in late 90s. Later on, scientists, once the structure was confirmed, the scientists started the synthesis of these compounds. Synthesis of quinine and cinchonine. This was carried out. So many different syntheses has been reported. Rabi synthesized, first report came from Rabi, who was a French chemist in 1931. Then, second report obtained from Prelog and Woodward. If you remember, this is the same Woodward name that you have already come across in Woodward-Field's rule in UV visible spectroscopy. So same Woodward and Prelog is the one who contributed towards the CIP rule, Khan in gold Prelog, if you remember. CIP rule in assigning the absolute configuration, priority order, if you remember. So both of these two scientists, Prelog and Woodward, both were American. They synthesized quinine in 1944, approximately 13 years ago afterwards. And next was Gates synthesis. Gates. not Bill Gates. This is some other chemist, Gates. So Gates presented this in 1970, and at the same year as Russian scientists, because at that time the Russia was also a superpower. Uskokovich is the name of the scientist who synthesized in 1970, and then he modified his scheme and synthesized again by another method, the quinine, in 1978. In 74, there is another report by Taylor. Taylor is the name of a scientist who synthesized this um, quinine. And the latest most synthesis has been done, the last synthesis in 2001 by Stock. So these are the different syntheses are being reported, but I am going to present you just one synthesis, which was done by Gates in 1970. So this is the laboratory synthesis of quinine, which was reported by Gates in 1970. So what he started with this compound, this is commercially available. This is just like a styrene. This compound is called styrene. This is meta-hydroxystyrene. This is used in polymerization, in polymeric materials. So he started with this. He reacted with this. This is a ethylene formate. Basically, this is a protective group, methoxy group. When methanol and this group aldehyde is here, this is basically uh, amino acetaldehyde. When acetaldehyde aldehyde group is protected with acetal, this is acetal, so it is reacted with HCl in the presence of methanol, so it results in this form. This is aldehyde, protected aldehyde. So what he obtained in the presence of sulfuric acid, this is being protonated in fact, so it becomes positively charged, making a living group. So this component which is present here, basically this nitrogen starts participating in that particular example. So what happens is that this group which is present as such here, it results in the cyclization of this group into this one, right? So this is how it is been synthesized. This nitrogen, you see, is this one, right? And this is the ring which has been formed at here. So these two, carbon and nitrogen, these are the two, carbon and nitrogen, are participating in this case. So it becomes different. So aromatic substitution takes place at this position. Again, this group leaves, generates a double bond. Nitrogen is free, which adds to this. In fact, this is also aldehyde, I think. The structure drawing is not right. This is not styrene. This is also aldehyde group. This nitrogen basically reacts with this, I forget, there should be an oxygen here, in fact, an oxygen here, just mark down an oxygen here. So this nitrogen makes a shift base with this double bond this, and then because medium is acidic, so this is protonated, and then we get this nitrogen, which is this one. Aromatic substitution takes place here. This bond takes place and double bond generates. This is not the required product. Your nitrogen is not at its right place. So you shall just come across this. It is not the right entity. So this is not the aromatic system. We are going to synthesize a cyclic system, which is this one, meroquinine, if you remember. So meroquinine, how it is synthesized, I am going to present. So in next case, formaldehyde and this cyclohexyl type six member nitrogen ring. So it undergo the basically first of all this nitrogen reacts with the form imine in the presence of catalytic amount of salt. Basically this hydroxy is ortho para director. Para is occupied. This ortho and this ortho. So two isomers are possible. This isomer dominate in fact. So we are getting this CH2. This is traveling. Basically, we are having a double bond at this position. but this nitrogen is positively charged. So this electron pair transfers there, and we get this aromatic substitution at this carbon, which is formed by the combination of this nitrogen with this formaldehyde. So in next step, what is done in the presence of sodium methoxide at 200 degrees Celsius? Why at that high temperature? The sodium methoxide picks up a proton, and basically what it generates is this molecule leaves from this system. It basically picks up a proton basically from this position. So negative charge generate, it donates electron pair here and kicks out this molecule from here. So we get a methylation at that place. Next is the hydrogenation or platinum. So when it is done, this carbon nitrogen double bond is reduced. And next, this is reacted with acetic anhydride. So nitrogen, which is generating here NH, reacts with acetic anhydride to form NC double bond O when it is being protected. Next reaction, you see Rene nickel. You are familiar with Rene nickel. Rene nickel is the name of a French scientist who used this nickel, which is an alloy of nickel and aluminum. When it is reacted with sodium hydroxide solution, it forms aluminates and generate atomic hydrogen. That atomic hydrogen is enough to reduce this aromatic system. Aromatic system doesn't undergo reduction, but under Rene nickel, it does undergo. You see, all of them are being reduced. And what is again hydrogen? Uh, this when it is been ring junction carbon are reduced, there are two possibilities. The hydrogen may add above the plane or it may add behind the plane. If it add above the plane, I have presented this isomer here. But another isomer shall also be formed in which you are getting both hydrogens here are above the plane. In other case, it shall be behind the plane, right? So we get the reduction of this molecule from here. But once this has been reduced, so it results first hydroxyl at this position. Then chromic acid is an oxidizing agent. It oxidizes basically this molecule, primary, secondary alcohol into ketone. This is how this isomer has been formed. In other enantiomer, you have two different isomers here. Fine. What is the next reaction? You see, in next reaction, we are having this is a ethyl nitrite, or it is also called ethoxy nitroso. What is the role of this? In fact, it reacts with this entity. It is going to break the bond between these two systems. You see, this is the carbon bonded with oxime, nitrogen, OH, this ethyl leaves, and we are getting nitrogen. This is just like an oxime C double bond O, and we are having this bond is broken. It oxidizes it from this place. Oxidizes it from this place, right? So it is been oxidized into carboxylic acid. You have CH2, CH2 carboxylic, CH2, CH2 carboxylic. And this group is been oxidized into C double bond with nitrogen, which is this one. And this has been oxidized. You see, this has been converted into this end. And when this is being hydrogenated in the presence of platinum, what is happening? It causes the reduction of this carbon nitrogen double bond. This group leaves and you are getting this amino group at this place. So this molecule can also be presented likewise. If you look at the structure of meroquinine is very similar to this, just one step away. Why one step away? Because if we are having this amino, if I react this with acid, heat this, so this amino shall be protonated and we shall get a carbon-carbon double bond here. So this is very close to in structure to the meroquinine. All right. So let's see if we proceed further. In this case, the same compound I have highlighted in previous example is this one. This has been further reacted with iodomethane in the presence of potassium carbonate. This is the methylating agent. So what happened? Idomethane basically protonates this NH2 group. When it protonates this, right? So it makes it a good living group. First, it is primary amine, converts into secondary amine, then tertiary amine, then quaternary amine. So it leaves and water molecule potassium hydroxide approach here. So NH2 group is been removed by this, right? And in the next step, it is been reacted with HCl. So what obtained that this basically is been carbon-carbon double bond we are obtaining. Then it is reactive with benzoyl chloride to protect this nitrogen. This nitrogen is protected at benzoyl amide. What happens? This is the, you can see meroquinine. If I show it again, you see I have presented the structure. This is very similar to that. This is meroquinine. This is meroquinine, right? So, sorry. This is meroquinine derivative. And in this case, this TAN structure can be resolved. It is reacted with quininic acid. This is a natural product. So it has also been successfully synthesized by Gates. I shall show in next lecture its synthesis. But this is already a natural product. So when these two meroquinine and this structure number 11 quininic acid were added, so what we get, this carboxylic group is basically at this position. You have a CH2 group. I think I have missed a CH2 group here. We should have another CH2 group, CH2, CH2, then carboxylic. So we have two CH2 groups here. So I missed basically one of them. So I shall present that here. So anyhow, in this case, this X is carboxylic group because space was insufficient. That's why I just written here X. So what is happening in the presence of sodium ethoxide, which is a good strong base reducing agent. So this is the recipient, carbonyl, and this is donor because when we react with sodium ethoxide, it exists in enol form. It picks up a proton from here and generates a negative charge. This acts as a nucleophile and adds to this carbonyl carbon, remove hydroxyl group from here, generating a new carbon-carbonyl bond here. So carboxylic group is attached. In next, it is being heated in the presence of aluminum in ethanol. So this carbon dioxide leaves and we generate a CO2. Now you can see this is the complete structure of quinine having a disadvantages that these functional groups are not confirmed, that either they are racemic in fact. So all asymmetric centers are racemic. You see 1, 2, 3, 4, 5 asymmetric centers are there. 32 isomers are possible with quinine, but only one quinine has been synthesized. This is how Gates synthesized it. Once this was synthesized, very first synthesis when it was reported in 1944 by Woodward and Prelog. So it was a very breakthrough. This is a time when Second World War was in progress. So at that time, this was the breaking news of that time. It was the breaking news of that time, not the ceasefire. So in 1950s, the largest news was the synthesis of malaria. Sorry, synthesis of quinine, not the ceasefire of Second World War. Why? Second World War has caused casualties in thousands. Malaria has killed in that decade, 1940 to 1950. Malaria has killed people in millions. How you can make a comparison between thousand and millions? Huge difference, 1,000 times difference. Malaria killed more people in that decade, 1940 to 1950. This is the time when the Second World War is also going on. Second World War, the soldiers which were killed were less in number, thousands. And people died by malaria was millions. This is the difference I wanted to present, that it was the synthesis of quinine because now the quinine was available as a hand. So till then, quinine is being used as a remedy. But afterwards, in 1960s, 70s, the quinine became ineffective. In next lecture, I shall show that some other derivatives of quinine were used, mefloquinine and mesilquinine, which is being used these days, are being used, in fact, as a remedy against these ones. Um, so I hope I shall stop here. So this is all about your syllabi. So I shall try to finish a few lecture about this quinine in next week. If I shall upload my paper and see when it is scheduled. So next week we are having your examination. So I'm not sure what date it shall be. So I once I confirm tomorrow, I shall let you know. And if there is no clash of your paper by 8 o'clock, the lecture shall continue. Lecture shall not stop next week. That is also a teaching week. So, but if there is a clash of any paper that you are having, let's say your minor or your major subjects, so then we can get the class off. But otherwise, if there is no clash, the classes shall be on regular basis. Is it clear to everyone?
Yes, sir.
Yes, sir.
Right. So session is open. If anyone have any question,
No, sir.
have a good day.